Okay, I want to draw an exterior tangent between these two circles. Now, an exterior tangent is a tangent that touches off the two circles and just skims off the outside of the two circles like that. Now, if we wanted to find a point of contact between that tangent and, let's just say, this circle, what we do is we go at 90 degrees to the line of tangent through the center of the circle, and that would give us our point of contact here on the circle. Okay, but well, that's the property and the principle that we use to draw this exterior tangent, right? And that's based on drawing a triangle in a semicircle. So if I draw the semicircle here, okay, now this is the center of the circle and this is the diameter of the circle here. If I draw any triangle using the diameter of the circle as the base and the triangle touches off the circumference, the angle at the circumference will be 90 degrees. Again, if I use the diameter as the base, from there to there, that's the diameter of the circle, and if I draw, using that as a base, any triangle that will touch the circumference, then that angle will be 90 degrees, and that's true for every single triangle drawn with the diameter of the circle as the base of the triangle and the angle of the triangle touching the circumference. Okay, it'll always be 90 degrees. So this is an exterior tangent we're drawing. And for exterior tangents, we need to subtract radii. So this circle here, the large circle, is radius 50. The smaller circle is radius 30. Okay, so radius 50 minus radius 30 is equal to radius 20. So what we do is we put 20 mil, radius 20 mil on our compass, and we put the point of our compass in the center of the radius 50 circle, and we draw our radius 20 circle. So that's radius 20. The next thing we do is we join the centers of our circles. We take our compass and we bisect that line. We want to find the middle of it so we can draw our semicircle. So set the compass up to a distance greater than half of the line, and then swing it from both ends of the line and we will get, that gives us a line that will bisect that line. It'll give us the center of it and it'll allow us to draw our semicircle. So if I put the point of my compass there in the middle of the line and I draw my semicircle, these are all light lines and construction lines, what I get is an intersection between the semicircle and my radius 20 circle. If I take my set square and I radiate a line through the intersection of the radius 20 circle and the semicircle, where that cuts the radius 50 circle, that's a point of contact. Now just so we see really what's happening here, if we draw a line from the center of the radius 30 circle to the point on the small circle, what we're doing is we're actually drawing a circle from a point, we're drawing a tangent from a point to the radius 20 circle. And what actually happens is the tangent that's drawn to the outside of these circles here is going to be parallel to that line. So what we need to do is bring this line and draw it through the center of the radius 30 circle. Set off my sliding set squares. Slide my line down through the center of the radius 30 circle. Continue it out like that. Just highlighting the point of contact. I have a point of contact here. I have a point of contact here. I can draw my tangent between those 2 points. It shouldn't cut into the circle. It should just skim off the circle. Those points of contact is exactly where it touches both circles. Okay. That there is 90 degrees. This is our tangent, our exterior tangent. At 90 degrees to the tangent, through the center of the circle gives us our point of contact. The same here, at 90 degrees to this tangent, through the center of the circle gives us our point of contact there. And that's always also 90 degrees in there. So these lines just happen to be parallel. Well, don't just happen to be parallel, they are parallel. Okay, so the property that this is based on is this here. In a semicircle, every triangle drawn with its base as the circle diameter. And its angle at the circumference. So for every triangle using the diameter, there's the diameter, drawn in a semicircle using the diameter as its base and its angle here at the circumference. See your circumference. The angle at the circumference will always be equal to 90 degrees, always. So here's a semicircle, here's a diameter, here's the angle formed at the circumference.